In this lesson, we're going to examine how to express subsets, unions, and intersections in set notation. So some quick vocab off the start. A set is simply a collection of objects, and each object in the set is known as an element. The sets that you're very familiar with, or should be at this point, would be your sets of real numbers, and I'm going to extend that today into our imaginary and complex numbers. The first set of numbers you've learned would be the natural set, which is your counting set. So you write your sets in braces. So the natural set is 1, 2, 3, and then I have a comma followed by 3 dots known as an ellipsis because they continue forever. Your next set is the whole numbers. The only new number here would be 0, and then every other natural number is included. The set after that is known as the integers. And the integers include everything from the natural and the whole numbers, but also their opposites. So this looks like this, and I have an ellipsis on either end to show that they go infinitely in both directions. You may have noticed that I have a z here to represent the set of integers, and that's because an I goes with a more important set of numbers. You also may find that different textbooks use different capital letters. The next set is the rational set, which is any number that can be written in fraction form. Specifically, it's the quotient of two integers, which I'm calling a over b. So that's going to include all of the previous numbers, which we're going to call subsets of the rational numbers. And now you're going to have your terminating decimals like 0.5, because that can be written as a fraction, your repeating decimals. So irrational then would be any number that cannot be written in fraction form, which would be your non-repeating and non-terminating decimals, which pi is a famous classic one, but there's others. A lot of your square roots, like the square root of 2. Now, something like the square root of 4 would actually be over here in natural because that's equal to 2. All right, square root of 5 is over here. All right, now I'm going to jump outside. Well, first I need to mention that this makes up the real numbers. We use this fancy R for the real numbers. That's everything mentioned here, and that's where most values in everyday life fall. But now we have other numbers. We have the imaginary numbers, which are just poorly named. They are defined as, the most basic one would be the square root of -1, which is equal to I. And so the square root of any negative value, like the square root of -5, is going to be imaginary. Which leaves me with my final set we're going to talk about, which is our complex numbers. And complex numbers are in the form of a plus bi. We will talk about that more in this course, where a and b are real numbers. And I, of course, is imaginary. Okay, so looking at this, these are sets of numbers. Some are subsets, like the natural is a subset of the whole numbers, and the whole is a subset of integers. Irrational and rational are what we call disjoint, and we'll define these terms in our next few seconds here. On the screen, you're going to see some symbols that you must learn, and I will use them as we go through the video, so you may want to pause and write these down. On the screen, I have a universal set, which is often, we use kind of a script U for that. It looks like a printed one in this picture. And we often use a rectangle to call this our universal set. And within here we have two subsets. A is a subset of the universal set, and B is a subset of A. Because B is completely inside of A, we call it a subset. And that symbolism would be written like this. It's like a sideways U. B is a subset of A. And here it is printed a little neater. Let's use the following example to talk about these vocab words. So a universal set is often denoted by kind of a script U, and it is your set of all possible elements. This is going to change from scenario to scenario. An element of a set kind of looks like an E, or capital C on its side with a line in it. It's any object that belongs to a set. And we defined that already, so I'm going to give you an example from here. So I can see that the number 3 is an element of set A. I could say that 2 is an element of B. Both of those are true statements. So a subset is like this sideways U, and it's of course a set completely contained in another set. So here I'm going to say that A is a subset of the universal set. Now the complement of a set, first of all, it's written like this. So A complement, or the complement of A, would be all the elements not in a given set. So in the given example, A complement, written in set notation, you open up a set of braces. It's always good practice to order your numbers from least to greatest. So U is the universal set. So everything outside of A would be 0, 6, 7, 8, and 9, and I close my braces. So B complement, or the complement of B, would again be everything that's in the universal, because it's the set of all possibilities, but not in B. So that one, again from least to greatest, would be 0, 1, 3, 5, 7, and 9. Now, you could be asked, so what's the complement of the universal set? Well, since the universal set is everything in this possible scenario, it would be the empty set, which you can just write as 2 empty braces, or more familiar would be the circle with the slash through it.